Welcome to my channel, Engineering Lectures Made Easy. Hello everyone. Today in this video, we are going to discuss about DBSCAN algorithm. So DBSCAN algorithm is a density-based spatial clustering of applications with noise design clustering algorithm. So density-based clustering locates regions of high density that are separated from one another, the regions of low density. So DBSCAN is one of the effective density-based clustering techniques. So it is used in many applications, mainly for its efficiency, resistance to noise, and ability to deal with arbitrary shaped clusters. The main idea is divide the noise from objects to clusters. So objects to clusters equals dense points, and noise is low density points. So density-based spatial clustering of applications with noise is basically having three main criteria to be known. One is the density, where it is a number of points within a specified radius. It is also called as EPS. A point is a core point if it has at least a specified number of points, that is the minimum points within EPS. So basically, we are going to understand three main terminologies here. One is the core point, border point, and a noise point. So a core point is a point which satisfies the criteria of minimum points, and it should be within the epsilon value. EPS stands for epsilon. You can also relate it as a radius. So these are points that are at the interior of the cluster, and when you are counting the core point itself also should be counted for satisfying the criteria of minimum points. So coming to the second topic, which is a border point. A border point is not a core point, but is the neighborhood of a core point. So basically, a border point is not a core point, it is a neighborhood of the core point. So that we will see when I solve the numerical. Next is a noise point. Is any point that is not a core point nor a border point. So the points which are neither coming in the category of core point nor coming in the category of border point, we will consider that particular point as a noise point. So coming to the DBSCAN algorithm, it eliminates noise points and performs clustering on the remaining points. So let us move on to the actual algorithm of DBSCAN. So the first step in algorithm is label all points as core, border, or noise points. Next, eliminate noise points. Put an edge between all core points that are within EPS, that is the epsilon value or the radius of each other. Make each group of connected core points into a separate cluster. So after forming a cluster, we'll find out which is the core point, and next is we'll find out which is the border point. The last step here is assign each border point to one of the clusters of its associated core point. So as we have seen the definition of the border point, a border point is not a core point, but it is nearer to the core point. Then it will be considered as a border point. So border points can be neighbors of several core points or clusters. So arbitrarily choose one. So this is the algorithm of DBSCAN. So let us have a look about overview of how the DBSCAN algorithm works and what are the noise points, border points, and the core points. So here we can see a circle of radius around 3 centimeters, which is an epsilon value. Here A is considered as the core point. From A, we are drawing a radius of 3 centimeters, and the condition given is minimum points is equal to 7. So how can we derive to a conclusion that A is a core point is it should satisfy the condition as minimum points. That is, when we count the points within the radius of A, there should be minimum of 7 points. Then we can say that A is a core point. So let us start counting. So here is the first point: 1, 2, 3, 4, 5, 6. Yes, 6 points along with the point itself. Along with the A.4 itself, it forms a 7 points, which is formed as a cluster. So when A satisfies the criteria of minimum 7 points within its radius, this can be considered as a 4 point. Moving forward, next we will see what is a border point. Now let us consider B as the border point. After considering B as a border point, draw the radius or epsilon value of 3 centimeters around B. So when you draw a circle of radius 3 centimeters, it is covering these two gray points and the A point. So now we will check the condition whether it satisfies the minimum points. So minimum points is equal to 7. So when we count the points within the radius of B, it is 1, 2, 3 and 4. No, it does not satisfy the criteria of minimum points. So thus it cannot be considered as a core point. Now, when it is not considered as a core point, you have to check whether it can be considered as a border point. Yes. Now, a border point is a point which is nearer to the core point. Yes, it is nearer to the core point. So hence, B can be termed as a border point because it is nearer to the core point, and it cannot be considered as a core point because it is not satisfying the criteria of minimum points, which is 7 in number. So coming to the next point, which is C. Again, we will check whether C is a core point or a border point or a noise point. So we'll categorize it. Now, do the same step. Around C, put the epsilon of radius 3 centimeters and draw a circle. So when you draw the circle, these points will be lying inside the circle. So when we count the points within the radius of C, it is 1, 2, 3. Okay. So now we have to check whether it is a core point. No, it is not a core point because it is not satisfying the criteria of minimum points of 7. So here we are considering C as not a core point. Now we'll check with the condition whether if C is a border point. Now C is not nearer to any core point. So core point is A, is not nearer to A. So hence C is not even a border point. So lastly, the only left out point which is neither a core point nor a border point, it is a noise point. So C, now it is considered as a noise point. So this is the depiction of how to categorize core points, border points and noise points. So here I have got your diagram of understanding how the original points are there, and here you can see the point types are core, border and noise. So the core points which is depicted here in the green color, the border points are in the navy blue color, and the noise points which are not necessary in this picture is represented by red color. So this is basically the DBSCAN. We'll go with a numerical on DBSCAN algorithm. So consider EPS is equal to 2 centimeters and minimum points as 4. Demonstrate DBSCAN algorithm with the points C 1, 2, 3, 4, 5 and 6. Now the radius given is 2 centimeters. So the step 1, let point 1 be chosen as a core point. So I'm out of 6 points and choosing point 1 as the core point. So after choosing 1 as the core point, I'm drawing a radius of 2 centimeters around 1. So when I draw this radius of 2 centimeters, now I'll check with the condition whether it is a core point or not. So the condition for core point is it should be a point which is the interior in the circle and it should satisfy the criteria of minimum point. So when you see here, counting 1 itself in the count, so it is 1, 2, 3 and 4. So there are totally 4 points which is satisfying the criteria of the core point. Hence I am forming a cluster called C1, which is 1, 2, 3 and 4, and 1 is now a core point. Now going to the second point, let us consider 3 as a point. Now, after considering 3 as a point, we'll apply the drawing of radius, which is 2 centimeters around 3. So when I consider 3 as the point, center point, and draw the radius of 2 centimeters, now 1, 4 and 5 are the points which are covering inside the cluster. Now we will check whether 3 can be considered as a core point. Now when you count the points, it is 1, 3, 4 and 5. So totally there are 4 points within the radius of 0.3. Hence, 0.3 can also be considered as a core point. Now I'm forming the second cluster, which is 1, 2, 3, 4 and 5. So hence, here we have 2 core points, which is 1 and 3. Let us go on to the next step, which is step 3, where I'm choosing 0.5 as a point whether, and now we have to check whether it is a core point or a border point or a noise point. Now drawing the epsilon value of 2 centimeters around 5. So here when we draw a radius of 2 centimeters, so 5, 3 and 4 will come in the radius range of 5. Now when you count the points within the range, it is 1, 2, 3. So there are only 3 points within the range of 5. So hence the condition of core point will not be satisfied because we have to have minimum points as 4 to be considered as a core point. If it is not considered as a core point, we have to check whether it is a border point. So how to check whether it is a border point? It should be nearer to one of the core points. So hence we can see here, now in the previous step we have computed that 1 and 3 both are the core points. Now we have to check whether 5 is nearer to 1 or 3. Yes, it is nearer to 3, which is a core point. Hence 5 is considered as a core point. Sorry, it is considered as a border point. So 1 and 3 are considered as core points and 5 is considered as a border point because it is not satisfying the criteria of minimum points as 4. Hence it is considered as a border point. Now we'll consider the point 6, which is a point which is lying here outside the clustered range. So here when you draw the radius of 2 centimeters, here we can see none of the points are coming inside the range of 0.6. So hence 6 can be considered as a noise point. So here 1 and 3 are considered as the core points, 5 is considered as the border point and 6 is considered as the noise point. Thank you for watching the video. Subscribe for my channel for more tutorials on data mining and data warehousing subjects and other computer related subjects. Thank you.